Alright, we've got one more video for this last section. And in this video, we are going to talk about our review of inequalities, including graphing, set notation, interval notation, and solving. Alright, so the first thing we want to talk about is graphing inequalities on the number line. And just a reminder, when we talk about inequalities, we are talking about statements where it's not just equal to. So for instance, anytime you see something like a less than, a greater than, less than or equal to, greater than or equal to, and also one that you will encounter, we'll encounter it a little bit in this class, but you'll see it also in future math classes, is the not equal to. In order to graph inequalities on the number line, the first thing that we want to do is we want to plot the critical numbers. The critical numbers are the numbers that are in the inequality statement. From there, you want to shade the side indicated by the inequality. If you are talking about numbers that are less than the critical number, we go to the left. And if you are talking about numbers that are greater than the given number, then you want to shade to the right. If the variable is in between two numbers, we aren't going to see it in this class, but in future math classes, you may see something called a three-part inequality. And if the variable is in between two numbers, we want to shade between the two numbers. Finally, we want to identify what happens at the critical numbers. If it is a strict inequality, meaning it's strictly less than or strictly greater than, we use a parentheses or an open circle, and we want it opening towards the shading. If it is not a strict inequality, so if it's a less than or equal to or greater than or equal to, we use a square bracket or a closed circle, and again we want it opening towards the shading. Alright, so we're going to go ahead and look at some examples of graphing. And just so you know, you can make these as precise as you want in terms of plotting the number. But because we've already talked about plotting numbers, and I think everybody is okay with that, I'm going to show you the bare minimum of what you need to do in order to graph these. So if we start with x is greater than 5, we have our number line. And again, you can either plot 5 precisely, or if you want, we just want a tick mark and we want to label it as 5. I am okay with this. All right, the next thing we want to do is we want to identify what direction do we want to shade. And so we are looking at the numbers that are larger than 5. Those are going to be the ones that if we plug them in for x, we get a true statement. And so the numbers that are larger than 5 are the ones that are on the right side. So we are going to shade this direction. Finally, we want to know what happens at 5. We want to know, is it included or not? Here, 5 is not included. And so what we are going to use is we are going to use a parenthesis, and we want it opening towards the shading. Again, you can use an open circle. And the reason that we have kind of switched notation to the parenthesis and bracket is because of interval notation, which we'll look at on the next slide. Now, when you do put your parenthesis, your bracket, your open circle, or your closed circle, make sure that you are putting it on the tick mark. Do not put it a little to the left or a little to the right, because then now it makes you wonder, okay, is the number included or not? And we do want it to be right at that tick mark. All right, let's come over to example B. Example B, we have x is greater than or equal to -2. So again, I'm going to start by putting my tick mark. I'm going to label it. And then I want to know what direction are we going to shade. So where are the numbers that will satisfy this? We want numbers that are bigger than -2, which means that we want to go to the right side. We want to indicate whether -2 is included or not. And because this is an or equal to statement, it is included, and we denote that with a square bracket. Again, you want to make sure that it is on the tick mark. The way that I kind of remember these is if it does have the line underneath, I want, something solid. I want, something square, and that's where we use the square bracket. Whereas if it does not have the line, I want to kind of make it kind of loosey-goosey, and so we use a parenthesis. All right, let's look at two more. Example C, we have x is less than -3. And so we are going to start by drawing our number line. We have our tick mark, we label it as -3. And now I want to know where are the numbers that are less than -3. This is going to be to the left, and so that is the direction that we shade. And then we also want to know what happens at -3. Because this is a strict inequality, we are going to use a parenthesis. And finally, our last example, we have x is less than or equal to 4. We have our tick mark. We have our label. We want the numbers that are less than or equal to 4, which means that we want to shade to the left. And we want to know what happens at 4, because it is a less than or equal to, because it is included. We want a square bracket. Now, one of the things to note is that if you have your variable on the left side, you can treat the inequality symbol as an arrow pointing the direction. So for instance, x is greater than 5. I can kind of create a little arrow here, and it's pointing to the right. And similarly on these other ones, x is less than or equal to 4. I can kind of put a little line in there, and it looks like an arrow pointing to the left. Now the important thing to note is that you can only use this trick if your variable is on the left side of the inequality. If we flip it around, for instance, A, if I say 5 is less than x, well, this arrow is not going to point in the correct direction because this is the same statement as A. We want to know where are the numbers larger than 5, and so it's still over here. And we still have our parenthesis. And so again, if you recall when we talked about equations in the previous section, we talked about, some people always wanting their variables on the left and some people always wanting them positive. With inequalities, it's always a good idea to put them on the left side so that you can use this trick in order to figure out which direction to shade. All right, the next thing that we're going to look at is different ways to write the solution set for inequalities. The first thing that we have is set notation. When writing an answer in set notation, we use squiggly brackets. Inside the brackets, we put the variable or variables, a vertical line, and then our statement using inequality notation or whatever notation it is we're wanting. So for instance, if you have an inequality x is less than 4, then the answer in set notation is x. We have our vertical line, x is less than 4, and we encase it in squiggly brackets. Mathematically, you'll find that as you get further in math, mathematicians like to use lots of different symbols to represent things because they don't like writing sentences for some reason. But for instance, these 7 little symbols read all values of x such that x is less than 4, or all values of x that satisfy the statement x is less than 4. The second way that we can write our solution set is using interval notation. Now, when using interval notation, it is recommended that you graph first. And we're going to basically write a shorthand number line using interval notation. So the first thing that we want is we want to list and separate the leftmost value and the rightmost value with a comma. We are going to encase these in parentheses and or brackets using the same symbols that you used for your graph. If the graph goes on forever, we use an infinity symbol, which is a sideways 8. If it's going forever to the left, we use a negative infinity because at some point you cross over 0 and you're in the negative side of the number line. If we are going forever to the right, we use a positive infinity. One thing to note, you cannot equal infinity. So for both of these symbols, you will always use a parenthesis, whether it's positive or negative interval notation. So a few things to note. We will not be placing a lot of emphasis on set notation. The book introduces domain and range before discussing inequalities, and so we will use set notation for any of the assignments in chapters 1 through 3. When writing answers in set notation, make sure that you do not use the infinity symbols. We only use the infinity symbols when we are doing our interval notation. When completing your homework, the program will ask for you to write the answer in interval notation before graphing. And I do recommend that you graph the solution set on your paper before writing the answer in interval notation. Again, because interval notation is a shorthand number line. And so it's easier to do the graph, figure everything out there before trying to come up with your interval notation. All right, so let's go ahead and look at some examples now. We are going to write the answers in set notation and interval notation. Again, set notation, don't worry so much about this one, but it's very easy. So remember, set notation, we are just going to do our squiggly brackets. We are going to put our variable. We have our vertical line, and then we say x is greater than 5. For our interval notation, we have our graph here. And so the first thing we want is we want to know what is the leftmost value of the shading and the rightmost value of the shading. So this shading, it goes to the left. The leftmost value is a 5. And then we want to know how far to the right does it go. Well, it goes forever to the right, which means that it is infinity. From here, we want to figure out whether we want to use brackets and or parentheses. Remember, infinity always has a parenthesis. And to figure out 5, we want to look at our graph and see, okay, did we use a bracket or a parenthesis there? We used a parenthesis on the 5, and so we are going to use the exact same parenthesis in our interval notation. And so this is our interval notation here. 5 comma infinity inside parentheses. All right, let's come to example B. Example B, we have x is greater than or equal to -2. So again, with our set notation, we are just going to go x. We're going to put our vertical bar. We have x is greater than or equal to -2. And we close our squiggly bracket. All right, for our interval notation, how far to the left do we shade? And the furthest value of the shading on the left side is -2. And on the right side, it goes forever to the right, and so this is a positive infinity. Again, infinity will always have a parenthesis. And for -2, we want to use the same symbol that we use on our graph. And so we are going to use a square bracket. All right, let's go ahead and look at the last two now. Example C, we have x is less than -3. And so our set notation, we have our squiggly brackets. We have our x, we put our vertical bar. X less than -3, we just copy the inequality. And then we close our squiggly brackets. All right, for our interval notation, I'm going to go a little bit backwards. Our rightmost value is the -3. And so in our interval notation, this is going to go on the right side. And on the left side, we are going forever to the left. And remember that over here, we are talking the negative values, which means that on this side, we have -infinity. -infinity has a parenthesis because we cannot equal it. And here we note that on our -3, we have our parenthesis, which means that we want a parenthesis in our interval notation. All right, last one. We have x is less than or equal to 4. So again, our set notation, we have our squiggly brackets, we have our x, we have our vertical bar. We copy the statement here and close our squiggly brackets, and we're done. All right, for our interval notation, our rightmost value, again, I'm going to go backwards, is +4, which means that in my interval notation, that is going to go on the right side. And on the left, we are going forever to the left, which means that this is -infinity. -infinity will have a parenthesis. And on the graph, we used a square bracket at 4. We want to use the exact same square bracket in our interval notation. All right, so that takes care of set notation and interval notation. Let's go ahead and move on to our last thing, which we're going to talk about solving inequalities. All right, so let's finish up this section. Now we're going to actually talk about solving linear equalities. So the first thing that we want to do is solve the inequality using the same procedures for equations. The only difference between inequalities and equations is this next step. If you multiply or divide both sides by a negative, you need to flip your inequality sign. You can still check your solution, and the way to check this is pick a number that is not the critical number that works in the final inequality and plug it back into the original one. If you still get a true statement, then your inequality symbol is correct. All right, so let's go ahead and look at some examples. All right, so for all of these problems, we are going to want to wrap up all of this. We are going to solve, we are going to graph, and we want to write the answer in interval notation, not set notation, interval notation. All right, so let's look at example A. We have t plus 5 is greater than 1. And so again, we're just going to kind of use our same techniques. We want to get t by itself. So in order to do that, we want to subtract 5 from both sides. On the left, our 5's cancel, and we are just left with a t. 1 minus 5 is -4. And now, did we multiply or divide by a negative? And the answer is no. So we are going to keep the same inequality sign. So we get t is greater than -4. All right, so for instance, let me just show you kind of the quick check step. Pick any number bigger than -4. Don't think too hard about it. I'm going to go with 0. And if we plug in 0, we get 0 plus 5 is greater than 1. And just like with equations, we just want to simplify each side. We get 5 is greater than 1. Is this a true statement? And it is. Okay. All right, so now we want to go ahead and graph this. So just like we did earlier, we have our number line. We have our tick mark. We are going to label it as -4. Do we want to go to the left or the right? Since my variable's on the left, I can go ahead and follow the arrow, which means I want to shade the right side. And because this is a strict inequality, we want to use a parenthesis. All right, now we want our interval notation. And for our interval notation, our leftmost value is -4. This goes forever to the right, and so we have positive infinity. -4 is a parenthesis because that's the symbol I used on the graph, and infinity is a parenthesis as well because it's always a parenthesis. All right, so we are done with that one. All right, let's come over and look at a couple other ones. All right, let's look at example B. And I'm going to do this 2 times just to show you what you have to do depending on which direction you move. All right, so the first thing that I'm going to do is, as I mentioned, I always like solving inequalities and having my variable on the left. So I'm going to go ahead and subtract 5x from both sides. If we do this, we get -1x, or just -x, minus 1 is greater than or equal to, my 5x's cancel, and we have -2. All right, to finish solving, we want to add 1 to both sides. And if we do this on the left, we have -x. Our 1's cancel. We still have greater than or equal to. And now if we combine -2 plus 1, we get -1. And now here's the thing that we do have to remember that is different for inequalities. I want to divide by -1. And when we do this, we get that our negatives cancel on the left. We are just left with x. Our negatives cancel on the right, and we are left with 1. But because we did divide by a -1, we need to flip our inequality. And so we get x is less than or equal to 1. All right, let's do this one again real fast just to show you what happens. Remember that when we talked about solving equations, we said it doesn't matter what side you put your variables on or what side you put your constants on. They just have to be on different sides. So let's do this now, and instead of moving the variables to the left, let's move the variables to the right. So I can subtract 4x. We get -1. is greater than or equal to x minus 2. And then we want to add 2 to both sides. And we get 1 is greater than or equal to x. All right, we want to graph this. Now, the thing that I want to point out is if you are graphing this one, note you cannot follow the arrow. Remember, you can only follow the arrow if your variable is on the left. And if you notice here, we have 1 is greater than or equal to x. That means that my x values, I want them to be smaller than 1, which means I want the left side. Now, one thing you can do is if you do end up solving and moving your variables to the right, then I recommend that you just take an extra step and flip your inequality like that. We can switch the sides, we can put the x on the left, we can put the 1 on the right, and we still want our crocodile mouth opening towards the 1. All right, now we've shaded. We want to know what happens at 1, and so we do want a square bracket because it does say or equal to, and we want it opening towards the shading. All right, for our interval notation, how far to the left does this go? This goes forever to the left, and so it is going to be negative infinity. Our shading goes to the right up until 1, and those are our two values. Remember, negative infinity will be a parenthesis, and 1, we used a square bracket on our graph, and so we will use a square bracket in our interval notation. All right, let's look at a couple other ones. All right, you're going to see some that involve fractions, and so I just want to kind of show you the process for this. Example C, we have 2x plus 7. All of that divided by 5 is less than negative 9. And so just like with equations, the first thing that we want to do is get rid of our fraction. And because we only have one fraction, I'm just going to multiply both sides by 5. If we do this on the left, my 5's cancel, and I am left with 2x plus 7. And on the right, we get negative 9 times 5 is negative 45. We want to finish solving, so the next thing we want to do is we have all of our x's on the left, so I want to move all of my constants to the right. We're going to subtract 7. On the left, we have 2x. My 7's cancel. And on the right side, we have negative 45 and negative 7. These are same signs, so we are going to add. We get 52. We keep the sign. And again, we do not flip our inequality because this is not multiplying or dividing. This is just subtracting. From here, we want to go ahead and divide by 2. And we get x is less than negative 26. Again, we don't flip our inequality because we are not dividing by a negative. We have a negative in our division, but it is not the one that we are dividing by. And so we get x is less than negative 26. All right, if we go ahead and graph this, this is one of the reasons that I don't put a lot of emphasis on plotting this point, because I don't know about you, I don't want to count out 26 tick marks. We have our 26, we do have our variable on the left, and we can follow the arrow, and these are the numbers that are less than negative 26, and at negative 26 we have a parenthesis because it is not included. All right, our interval notation. This goes forever to the left, so we have negative infinity. On the right, it goes up to negative 26. And we want parentheses around both of these on infinity because it's always a parenthesis, and on the negative 26 because it is a strict inequality, and that was the symbol that we used on our graph. All right, last example, let's see what we can do here. All right, example D. We have 9 minus 2t divided by negative 3 is less than or equal to negative 7. All right, so for this problem, again, just like on the previous one, the first thing I want to do is get rid of the fraction. And so I am going to multiply both sides by negative 3. On the left side, they cancel out. We get 9 minus 2t. On the right side, we have 21. And remember that the rule for flipping the inequality is not just when you divide by a negative, but when you also multiply by a negative. So here, because we multiplied by negative 3, we need to flip our inequality sign. All right, we're going to continue solving. The next thing that we want is I have all of my t's on the left, so I want to move all of my constants to the right. Our 9's cancel. We are left with negative 2t. We have this is greater than or equal to 12. And again, we're not going to flip our inequality because this is a subtraction, not a multiplying or dividing. All right, and the last thing, to get t by itself, we want to divide by negative 2. Whatever we do on the left, we do on the right. On the left side, my negative 2's cancel, and I am left with t. On the right, we get 12 divided by negative 2 is negative 6. And again, because we did divide by a negative, I need to flip my inequality. All right, if we go ahead and graph this, I have negative 6. We want the numbers that are less than or equal to negative 6, so this is going to be going to the left. And because negative 6 is included, we want a square bracket. For our interval notation, this goes forever to the left, so we have negative infinity. It goes up to negative 6 on the right. Negative infinity will be a parenthesis, and negative 6 will be a square bracket. All right, that finishes our solving inequalities. And so the last thing that I want to point out is, okay, what are we going to do with this moving forward? Moving forward, we are going to be using interval notation when we discuss domain and range of functions over the course of this semester, using either equations or graphs. And this is something that you will continue to talk about in your future math classes. We will be solving inequalities when finding domain and range of functions. Mostly the first one that we have is radical functions, square roots, and in future math classes, you will also apply this to exponential and logarithmic functions. You will see inequalities in future math classes when you discuss things called piecewise functions, the greatest integer function, and in future math classes, you will also apply the concepts of solving inequalities to polynomial and rational functions. All right, but for now, that is it for this section. All right, next thing that we're going to talk about is review of graphing. And so I will see you again soon.